Hello GCC, this is the third video for chapter 12. So far we've learned how to go between atoms and molecules to moles using Avogadro's number. And then we learned how to go from moles to grams using molar mass. Well, I've got one more step here for you. It's called molar volume. That means the volume of a mole. And it says at STP, that is standard temperature and pressure. So volume, we're going to talk about gases. So if you look at the chart, I have several gases in the chart: hydrogen, fluorine, ammonia, xenon, and methane. I'm going to take 1 mole of each of those gases. Now remember, a mole is 6.02 times 10 to the 23rd molecules. And their masses depend on the periodic table, of course. So hydrogen's molar mass is 2.02. Fluorine's is 38.00. Ammonia's is different, xenon's is different, and methane's is different. They all have different masses because they're different atoms in the table. But it's still 6.02 times 10 to the 23rd molecules. Now, if we take these gases at standard temperature and pressure and let them take up space, how much space do they take up? This much? This much? Does it depend on the gas? Well, here's the weird thing. All of those gases take up the same amount of space, about this much, and it's 22.4 liters. So it doesn't matter what gas you have. If you have 1 mole of it, it takes up 22.4 liters. Now the masses are different, so shouldn't that take up different amounts of space? Well, not when you consider a gas has little bitty tiny molecules far apart with empty space in between them. The empty space is the same for all the gases. So the size of the molecule doesn't matter. So they all take up 22.4 liters when you have 1 mole. And so molar volume is 22.4 liters per mole of gas at STP. Gases are mostly empty space, so they all have the same volume despite the different mass. We just saw that. So molar mass again is 22.4 liters per 1 mole of any gas at STP, standard temperature and pressure, which, by the way, is 0 degrees Celsius, so cold, right when it starts to snow, and 1 atmosphere. That's the pressure at a beach, 1 atmosphere, so that's sea level pressure. So remember, STP is standard temperature and pressure, 0 Celsius and 1 atm. All right, get those calculators ready again, because it's time for more math. Yay, I know you're excited. So we're going to use our 22.4 liters per mole to do some calculations. Number 1, what is the volume of 1.25 moles of argon gas at STP? Start with what you know. 1.25 moles of argon. Now we're trying to find a volume. We just learned if you have 1 mole, it's 22.4 liters. But we don't have 1 mole. We have 1.25 moles. So we need to multiply by 22.4 liters per mole. So moles will cancel, and we get our 28.0 liters of argon gas. Okay, so there's the first one written out for you. Again, 1.25 moles of argon. Start with what you're given. We're given moles, so moles has to be on the bottom, so it'll cancel out. 22.4 liters goes on top, and we get 28.0 liters of argon. Now your calculator, when you do that, 1.25 times 22.4 just shows 28. Why did I add 0.0? Well, I did it because of significant figures, didn't I? I started with 1.25, 3 sig figs. 22.4 is also 3 sig figs, so I need 3 sig figs. So 28.0 is my answer for sig figs. All right, I want you to try numbers 2 and 3. I want you to hit pause. You got your calculator, you got your periodic table that you might need. Good luck. All right, I hope you practice number 2 and 3 on your own. Number 2, How many moles is 30.4 liters of oxygen gas at STP? Start with what you know, 30.4 liters. This time, we need liters on the bottom to cancel out. So we're going to write 1 mole over 22.4 liters. Liters cancel. That gives us 1.36 moles of oxygen gas. All right, number 3. What is the mass of 4.50 liters of chlorine gas at STP? This is going to be a two-step problem. It's a little bit more difficult. I hope you did good with it. So start with what we know, 4.50 liters of chlorine gas. We're starting with liters, so we need liters on the bottom. So it's going to be 1 mole over 22.4 liters, like that. Liters are going to cancel. We're into moles. How do we go from moles to mass? So moles to grams. We need a molar mass from our periodic table, yeah. Chlorine gas. Chlorine is diatomic, right? Have no fear of ice cold beer, diatomic chlorine. So we need to add up 2 chlorines. So it's going to be 35.45 times 2. That gets us the 70.90 grams per mole. Moles cancel, and we get 14.2 grams of chlorine. All right, so study those 3 right there. Hope you did a good job on that. So this table just summarizes what we've done so far. We have learned to go from grams to moles using a molar mass, or moles to grams. We have learned to go from moles to atoms or molecules using Avogadro's number, or atoms and molecules to moles using Avogadro's number. And we just learned we can go from moles down to volume of a gas at STP using the 22.4 liters per mole. The mole is the center, isn't it? You have to go to moles first before you go anywhere else. A lot of students memorize this chart, and then for exams, when you get scratch paper, they write this chart down and have it ready for the exam. So that's just a hint. All right, so we got 2 more examples. I want you to work on these. How many grams does 17.35 liters of neon gas mass at STP? And how many atoms is 17.35 liters of neon gas at STP? So, starting with the same thing, but I'm asking different questions. I want you to hit pause and try these 2 equations on your own. You'll need your calculator and your periodic table. Welcome back for those of you who did hit pause. Good job, by the way. Thank you very much for trying those on your own. Here is the first one. How many grams is 17.35 liters of neon gas? So start with 17.35 liters. We know a mole contains 22.4 liters. Liters needs to be on the bottom. Liters cancel, we got to moles. Now we're trying to get to grams. Every time you go between grams and moles and vice versa, it's molar mass. So we look up neon. Neon is 20.18 grams per mole. Moles cancel. We got our grams, 15.6 grams. Good job. Number 2. Starting with 17.35 liters again. Same step for the first step. 1 mole over 22.4 liters. Liters cancel. We got our moles. But this time, I asked for atoms. If the question involves atoms or molecules, you're going to use Avogadro's number, 6.02 times 10 to the 23rd atoms or molecules in a mole. This time we need moles on the bottom, so moles will cancel. 6.02 times 10 to the 23rd atoms is on top. We get 4.66 times 10 to the 23rd atoms of neon. That's a great place to end this video. All right, see you in the next video for Chapter 12. Good luck, GCC.